Swayam Prabha. Digital India. Educated India.
Hello everyone. Now what we will discuss the relationship between the speed of bobbin and bottom cone speed. As we know, the bobbin gets speed from the epicyclic gear, and which is actually the mixing of the variable speed which comes from the bottom cone drum and the fixed speed which comes from the main shaft, that we have already discussed in our last session. Now, you can see here the fixed speed from main shaft is mixed with the superimposed with the variable speed from the bottom cone drum through this epicyclic gear system. Okay. Here E1, E2, E3, E4 are the gear ratios. So, E1 is the gear ratio between the bottom cone pulley and gear having 50 teeth, which is nothing but the arm in the epicyclic gear system. E2 is the gear ratio between the 59 teeth and 62, that is epicyclic gear ratio, and E3 is the output of the epicyclic gear 62 teeth train to the bobbin, and E4 is the main shaft to the flat. So, these are the gear ratios, and we will get the relationship in terms of this E1, E2, E3, E4, and E1, E2, E3, E4 are constant for a particular set of gearing. Now, we can see here that this we have already discussed here, that is gear 50 is arm, 59 is sun, gear 28 is the planet, and from gear 25 the output gear 62 gets motion. So, these are the ratios, and this 85 is the epicyclic gear ratio, which is E4, E2 is the E2 is equal to 0.85. This is 8.85 is the epicyclic gear ratio E2. So, from this what we can get here, you can see from the bobbin speed NB, NB is the bobbin speed, what we get the speed of gear. So, we are going backward. So, bobbin is rotating at speed of NB. So, NB we know, and we are trying to calculate the relationship between the bobbin speed and the bottom cone drum speed. That is our relation between the bobbin speed and the bottom cone drum speed. Now, NB is the bobbin speed. So, if we go back to the output of the epicyclic gear, that is 62 teeth. So, N 62 teeth, that RPM will be at particular instant NB by E3. E3 is the between the output of epicyclic gear and the bobbin. So, that is the gear ratio between the output of the epicyclic gear to the bobbin. So, NB divided by E3 will be the output of the epicyclic gear RPM. So, relationship between the speed of main shaft and speed of the epicyclic gear train 62, that is main shaft means the speed of the sun gear and here sun gear is the input to the output gear, that is E2 is the epicyclic gear ratio is 0.85. So, N50, what is N50 is nothing but N62 minus E2 x. Now, you can see here gear 62 is 0.85 means E2 x plus y and 50 is means y. So, y will be N 62, this is 62 okay, minus E2 x, that means E2 you are getting. So, we can write these things E2 x plus y minus E2 x, and this is nothing but N 62 minus E2 x, and here y is nothing but N 50. So, from there we can write this relationship N 50 is y, okay. Y is nothing but 0.85 x E2 x, this is E2 x. So, E2 x plus y minus y. So, we can write minus E2 x. So, y we can write as like this. So, what is y? Y is nothing but N 50 and E2 x plus y is nothing but this N 62 minus E2 x. So, this is the things we can get from there. So, N 50 is equal to N 62 minus E2 x, okay. That is why it has come. Now, from here, now N 59, what is N 59? Is a sun gear. Sun gear is actually fixed on the main shaft NM which is x plus y. NM is equal to x plus y, and what is NM? Main shaft, that is NF. E4 is between main shaft and the flare. So, flare speed divided by F4. So, NM, so N59 equal to NF by E4. So, what we are getting? We are getting in terms of the epicyclic gear ratios. So, this is one relationship, here is another relationship N50 and N59. N59 in terms of E4, N50 in terms of E2. Okay. Now, x will be, what is x? Is x plus y minus y. So, x plus y minus y. So, x will be, what is x plus y? X plus y is NF minus E4 and minus y. From there we are getting x, and here we can see N50. So, N50 we have got N62 minus E2 and x is replaced by this one, and what is y? Y is nothing but this is N50. Okay. So, this is just replacement of the data. Okay. So, N50 equal to N62, that is the speed of the output of the epicyclic gear RPM, minus N50. What is N50? N50 is the arm gear. So, we are going gradually towards the epicyclic gear. So, because epicyclic gear gives the drive to N50. So, we have started from the bobbin and we are going towards the bottom cone drum, that is the approach. So, N50 we have reached here, because N62 N bobbin speed was there, okay, with the N62. So, we will try to correlate later. So, N50 we have reached here. So, in terms of N62 and N62 and in terms of the NF. So, NF, this is the relations. Now, you just we try to rearrange. After rearrangement we are getting N50 and this E2 N50 is going in the other direction, left side. So, N50 multiplied by 1 minus E2 equal to N62 minus E2 NF by E4. So, what we are getting? We are getting in terms of gear ratio. Now, N50 we can write, N50 will be N62 minus E2 by E4 multiplied NF divided by 1 minus E2. So, N50, that is the arm speed, we are getting in terms of fixed speed of the spindle and the output speed of the this epicyclic gear. Now, this output speed of epicyclic gear we are actually replacing with this value, with the in terms of NB. Now, we can see the here again the relationship. So, we have reached here in terms of the output speed of epicyclic gear and the spindle speed. Now, we will go back further. Now, bottom pulley RPM is N2 and N2 is nothing but N50 by E1, that is E1 is the gear ratio between the bottom pulley and 50, and this we have already seen earlier, that is N50, no sorry, what we have seen earlier, this is the things we have seen. N50 is N62 in terms of N62 and NF, okay, and E1, E2, E4 are the constants. Now, N2, that is N2 is nothing but N50 by E1. What is N2? N2 is the bottom cone pulley RPM, bottom cone pulley RPM N2, and N50 is the RPM of the arm. So, N50 by E1. So, what we are getting? We just replace these things. N50, this is the N50, this one, all these components are N50 divided by E1, which gives N2. N2 is the RPM of the bottom cone pulley. So, this from there we get, and what we are getting here, you can see N62. What is N62? N62 is the output of the epicyclic gear, and from there bobbin speed ratio was the NB by E3. So, N62 we have seen earlier, I will just go back, NB by E3, N62. So, N62 we can here replace by NB by E3. Now, we can see this N2 is related with NB, the relationship between N2 and the NB, bottom cone drum pulley, and the bobbin speed is related in this fashion, where E1, E2, E3, E4 are constants. And now, let us use the data, actual data of E1, E2, E3, E4, which could be calculated from the gearing ratio. Now, let us see. So, NB, this is from this equation we have seen here. So, N2 and N2 by bottom cone pulley and the bobbin RPM are related in this with this equation. Now, values of gear train ratio E1, E2, E3, E4 are 0.54, 0.85, 1.421 and 1.208 respectively. Hence, the bottom cone pulley RPM. So, this can be calculated. Now, let us see how to calculate E1, E2, E3, E4. Now, E1 is between the bottom cone pulley and gear of the train 50. So, bottom cone pulley to 50. So, that means your driver by driven. So, 27 divided by 50, 27 by 50. So, I will say just 27 by 50 is 0.5, 27 by 50, it will be 0.54, and epicyclic gear ratio we have already seen 0.85. Now, how to calculate 1.421? 1.421 is between the gear output 62 epicyclic gear output and the that gear to the bobbin 62 and the bobbin, it is 1.4141. Now, see from this gear to bobbin. So, it will be 81 by 54 and 36 by 38. So, in this way we can calculate that value, it is 1.412, and that E4 is between the main shaft and the flat. So, from there we can calculate, I will go back, 102 by 80, similarly 36 by 38. So, in this way we will get the value 1.2. So, if we now use this all this data in E1, E2, E3, E4, E1, so all this data, then what we get the value 8.7 multiplied by NB minus NF. That relationship we get if we replace all this data here, approximately we will get. And delivery speed of roving V is expressed in terms of meter per minute, and derivation of NB is given in the next two slides. So, NB now we will try to derive. Okay. This data we are getting 8.7 we are getting from using the all this data, all these values. Now, N2 will be 8.7 and NB minus NF is nothing but that is the winding RPM. NB minus NF equal to 1000 V divided by pi dB0's initial bobbin diameter plus 2 m minus 1 T. This is the m is the mth layer. Now, NB equal to NW plus NF. So, that means NW NB minus NF. Okay. This is NW. NW is nothing but 1000 V by pi dB that we have already seen earlier. Now, dBm can be replaced by dBm is replaced by dB0 plus 2 m minus 1 into T. T is the thickness of that we have already seen. So, this is the relationship. Now, here now we will actually try to get the derivation of NB, that is bobbin speed. Now, velocity of fiber strand delivered by the front roller speed is V millimeter per minute, and rotational rate is in RPM. So, bobbin speed NB and flare speed NF. So, winding speed are related in this fashion. So, winding speed NB minus NF. So, NB is NF plus NW. So, rate of winding must match with the delivery rate. Okay. If the bobbin diameter is dBm, then winding speed is this one that we have already seen earlier. Now, diameter of bobbin dBm increases from dB0 to dBf. So, initial bare bobbin diameter to the final bobbin diameter, empty bobbin to the full bobbin diameter respectively, and m the winding of mth layer of roving on the bobbin of thickness T. This is the relationship. Now, here with this diagram, with this relationship, we can calculate N2 is equal to 8.7 multiplied by 1000 V by pi dB, pi multiplied dB0 plus 2 m minus 1 T, that we have discussed here. Now, here the substituting the diameter of bare bobbin dB0 as 48. So, we have seen the bare bobbin diameter was 48, which is fixed in the machine, and then bottom cone RPM will be, this is the bottom RPM, bottom cone RPM will be 8700 by, so this is 1000 into 87, this is here 1000 you multiply. So, 8700 V by pi 48 plus 2 m minus 1 t, and here we can see that this is N2, and this pi, if we divide by pi, this value it will be 2770 V by this. So, this is the basic relationship we are getting in this one, and for the current gear plan, the delivery rate of the roving is 20.47, that we have already calculated. Hence, the required bobbin bottom cone RPM. So, now we have to calculate the bottom cone RPM. So, here it is a V is fixed, 20.47 is the fixed. Hence, the required bottom cone RPM is N2 equal to, it is a function of T and mth layer. So, bottom cone RPM is the function of mth layer number. So, number of layer if it is increasing, so bottom cone RPM will reduce, it is inversely proportional, and also if the thickness is increased, so bottom cone RPM will decrease. Okay. So, if we replace these things, this one V with 20.47, then we get the relationship N2 of this, okay, for any bobbin diameter. So, this is the bobbin diameter, for any bobbin diameter we can calculate the speed of the bottom cone drum, okay, and the bobbin diameter is related with the, in this fashion. So, N2 is 8.7 by Nb minus Nf, okay, Nb minus Nf, because the top, the RPM of top cone pulley is constant. Okay. So, that way, so what we have got here the relationship between the bottom cone drum speed and the bobbin speed, bobbin RPM, with having a constant flare speed. Okay. And we will stop here for this discussion, and then in the next session we will discuss the cone drum shifting, okay, mechanism of cone drum shifting. Till then, thank you.